Hello everyone, I welcome you all in this course Introduction to Sequence Stratigraphy, and as part of our discussion on sea level changes and the shoreline trajectory. So today we will try to understand the relation between base level and the shoreline trajectory. Already in the last class we have discussed about the concept of base level and how base level is controlled with respect to the changing energy condition in the sedimentary regime as well as the supply of sedimentation. So, we know that the interplay between base level changes and sedimentation, these two controls the fluctuations in the water depth, and that also controls whether there will be a transgressive condition or a regressive condition in the shoreline. I think you can remember about that basic accommodation equation T plus E equals to S plus W. So, that value W after the balance of T plus E and the S factor, that W will control whether there will be transgression or regressions. So, such shifts in shoreline condition, such shift in the depositional condition in the marginal marine area determines what will be the nature of the formation of the package of strata that will be associated with that particular depositional trend or that particular trend in the shoreline shift. So, that package of sedimentation, that sediment succession that will be forming under a particular phase of shift of the shoreline, it is commonly characterized by a specific stratal stacking pattern. So, already in the last class we have discussed about that, what are the different types of stratal stacking pattern, broadly 3 types we have seen. So, based on these arrangement of the stratal stacking patterns, we try to identify or we try to designate different system strats. So, when we talk about the accommodation and with respect to that the sediment supply, so there comes the condition that when the accommodation is relatively higher with respect to the amount of sediment supply, we can expect there will be a transgression, because in that case that W factor in that accommodation equation has to balance that equation. So, T plus E equals to S plus W, that equation, if the sediment supply is less and the accommodation creation by the left hand side of that equation T plus E is more, then the W, that is the rise in the water level and definitely its movement towards the landward side will be more, will be balancing the condition, and in that case we will get transgression. So, whenever accommodation outpaces the sedimentation, we commonly expect a transgression, that is the accommodation is created faster in these cases than it is consumed by the sedimentation. Whereas, on the reverse side, where we get very high rate of sediment supply, very high amount of sediment supply, which may result in a shoreline regression. That means, in those cases the amount of accommodation created is consumed more rapidly than it is being created. So, as a result of that, what we expect, there will be a regression, the shoreline will be shifting towards the sea. So, in case of transgression or in case of a regression, whether it is a normal regression or forced regression, we can always define in terms of a curve which we commonly call as the base level curve, or more commonly we can consider this as the sea level curve. So, this is a basic curve in this diagram. So, this can be considered as a basic sea level curve, or to be more precise, simple a base level curve. So, what is the meaning of this curve? This curve looks like a sine curve. It is going up and then it is coming down, and this horizontal axis, this is the time axis. So, along this time axis, the base level is showing some changes with respect to some reference point. So, that reference point is the 0 level. So, we are plotting that 0 level over here, which may be considered as maybe, say for example, reference to today's mean sea level, maybe the today's base level position, and with respect to that, when we start from some earlier time, we can observe the base level is changing or has changed through time. So, for some time it has risen up, it has gone to the maximum, and then it has come down. So, that is the fall phase. Then it has reached to the maximum extent of fall, and then from there it has again turned around and it has started rising up again, and again it has come to the peak of rise, and again from there it starts falling. So, we can consider this one as an ideal base level curve, because here we are considering this rise and fall as almost of equal amount of time involved over there, almost equal amount of rise and fall. But in natural system, the base level changes are not exactly similar. So, maybe in a natural system, a sea level curve or a base level curve fluctuation may be something like this, very irregular. So, for some time it is very high, for some time it is very low, and it is completely asymmetrical, completely irregular in nature. So, there are a lot of this kind of base level curve or sea level curve reconstructions are available in literature. So, I will suggest you to go through those publications so that you can get idea about these base level changes across time. But for our discussion, we are considering this base level as an ideal curve, looks like an ideal sine curve, where it is rising up, then it is reaching to its maximum, the peak, then it is falling down again. From that falling down position, it is reaching to the maximum amount of fall. So, this is the maximum fall, and from there it is again turning around and it is rising. So, this entire phase from here to here, this entire phase is the rise phase, and this entire phase from this point onward to this point onward, this is the fall phase, and it will go on like this. So, there will be rising phase reaching to the peak, again it will be falling down, there will be fall phase reaching to the peak of the fall, and then again it will start rising, and it will go on like this. So, commonly this phenomena, this transgression and regression, this shoreline trajectory, this can be represented, or we can understand this concept in terms of two different parameter. One, this base level change, and second one, another curve that we will propose is the transgressive regressive curve. We call it as TR curve. So, in this class we will try to understand what is the relation of this base level curve and the TR curve. But the principles remain the same regardless of the shape of the reference base level curve. So, to avoid these complications, in this particular discussion we will be considering this ideal curve, and if we can understand what are the phenomena, what are the processes that goes on with this rising and falling of the base level condition, we can apply that to any kind of curve in natural system in any case study. So, during the falling phase of the base level cycle, commonly the accommodation is reduced as expected, because when the base level is falling, that means overall sea level is falling and the amount of space available is decreasing. So, accommodation commonly gets reduced, and that is commonly controlled by the external controls, external factors like the interplay of tectonics, maybe some sea level change. So, mostly the allocyclic factors, allocyclic processes, and in response to that, the shoreline is forced to regress irrespective of the sedimentation factor. So, when we are looking at that falling phase, that falling phase will definitely lead to some regression irrespective of whether sedimentation is going on or not, and if sedimentation is going on, what is the rate of sedimentation, because even if sedimentation is going on and sediments are accumulating over there, it will lead to further regression of the shoreline. Whereas, the reverse can be observed during the phase of base level rise, where accommodation is created. So, during that phase water level is rising and accommodation is created, which is consumed by the sediments which are supplied into the system. Now, what will be the actual direction of the shoreline shift? It will depend on the interplay of these two competing factors, that is the amount of sediment supply and how much is the accommodation created over there. So, we can discuss in terms of these curves, these fundamental base level curves. So, during this rising phase of the base level cycle, accommodation is created and consumed at the same time. So, at this time what we can consider over here is another curve we can introduce over here. This was the first curve that we have already introduced, we have discussed. We can think of a second curve over here, this lower one, which is the rate of base level change. So, this curve is actually representing this one, but in terms of the rate of base level change with time. So, the horizontal axis is again the time axis, and with respect to that particular horizontal axis, we are just trying to understand what are the rate of change of base level at that particular time. So, if I try to understand what is the rate of rise over here, the rate of rise is quite high. In fact, you can see over here the slope of this curve is maximum in this part. So, the rate of rise is maximum over here. As the sea level is rising, but this curve is getting less steeper with respect to the time axis. That means the rate of rise is decreasing. So, that means in this part, if I draw somewhere here, if I take some point over here, so with respect to that point over here, the rate of rise is little bit less than this particular point. So, there is a phase difference between these two curves. When we are reaching over here, somewhere at this point, which is very close to the maximum rise of the base level. Still the base level is rising and trying to reach to its maximum level. And at that point, if you can see the slope of the curve, it is almost horizontal or having a very low gradient. So, that indicates the rate of rise is very low over here. So, when the curve will start falling from this part, initially the rate of fall will be low. When it will be reaching somewhere here, the rate of fall is maximum, and then it will be reaching to the maximum amount of fall when the rate of fall is decreasing again, and it is almost reaching to 0. But the amount of fall at that particular time is at its maximum, and then from here it starts rising, and at that point when it started rising, at that point the rate of rise is very low, as you can see from the shape of this curve, the gradient of this curve. So, the rate of rise is very low over here, and when it is reaching over here in this part, the rate of rise is quite high because the gradient is quite steep now. That means with respect to time, there is more rise in the base level condition. So, as a result, in this part we get the maximum rate of rise, and then again we are coming back to the previous situation, and it goes on like that. So, these two curves are fundamental curves. Basically, this is a single curve, but represented in two ways for our discussion. So, the base level curve, base level change, and the rate of base level change. Now, within this base level condition, we are introducing a second parameter, which is the rate of sedimentation, which is represented here with this green band. So, for simplicity in discussion, for our understanding, we are assuming that the sedimentation is going on at constant rate. So, throughout the process, the rate of sedimentation is not changing at all. It is going on at a constant rate throughout this base level change. So, that is why this green band is uniform throughout. Now, we can take cases one by one. Say we can start from here, this red zone. So, in this part, what is the situation? Base level is at its maximum, or it is trying to reach to its maximum level. So, base level is creating huge amount of accommodation, but the rate of base level change is quite low, as the slope of the curve is very low. It is a very gentle curve at this point, and that rate of base level rise or base level change is lower than the rate of sedimentation, as you can see over here in this part. So, what is happening in this part? Accommodation is created because the base level is still rising, but that accommodation is more consumed by sedimentation, because the rate of sedimentation is higher than the rate of rise of the base level. So, in such cases, what we expect? A regression. And since this is happening because of accumulation of sediments, supply of more sediments, so this is a normal regression. Now, when we reach over here in the second part, here the base level is falling, and already we have discussed just before this slide, I told you that when base level is falling, there will be regression irrespective of whether sedimentation is going on or not. So, in this part of the curve, starting from here to here, when the base level is falling, this entire region, this curve, the rate of base level change, that is in which rate the base level is falling, has no relation with rate of sedimentation. Since base level is falling, accommodation will not be created, rather it will be destroyed, and if some sedimentation is going on over there, it will further consume that accommodation. So, what we get is definitely a regression, and that is a forced regression in this part. Now, if I try to see over here this third part after the fall, so this portion. In this part, the base level is taking a turnaround, it is started rising up, and when it is rising, the rate of base level change, the rate of rise of the base level is quite low, because you can see the gradient of the curve over here. So, the rate of rise of the base level over here is lower than the rate of sedimentation. So, again accommodation is created from the lowest level of the base level, it is started rising. So, accommodation is created now, and that accommodation is consumed by more supply of sediments into the system. So, definitely there will be again a normal regression. And finally, we are coming over here in this part, in this particular zone, where the rate of base level change is higher, as you can see from this slope of this base level curve, and it is higher than the rate of sedimentation. So, in this case, the accommodation is created at higher rate than the amount of sediment supplied into the system. So, definitely there will be more space available, and we can expect a transgression. After this transgression, again we will get a regression, that regression that we have already discussed as the first case. So, throughout a base level fluctuation, what we can expect is, we can start with a normal regression, followed by a forced regression, followed by another normal regression, and finally a transgression, and this will go on in cycle. So, in this case, if I think of this particular base level curve, and if I try to draw a transgressive regressive curve over here. So, what we are getting over here, if I try to draw it in this part. So, in this area we are getting a normal regression, followed by a forced regression, followed by a normal regression. Then we are getting a transgression, followed by a normal regression, again a forced regression. So, this part of the curve is regression, this part of the curve is transgression, this entire part of the curve is a regression. So, what we can see, the regression is starting from here, which is not the end of the rise of the base level. The transgression is ending over here, and regression is starting from this point, which is not the peak of the rise of the base level. So, peak of transgression is not equal to the peak of the rise of the base level. Similarly, the peak of the fall of the base level is not equivalent to the peak of the regression, because as we can see over here, regression is still continuing even after the base level has started turning around and started rising. Even after that, there is a regression is occurring. So, there is a shift in terms of transgressive regressive curve and the base level change curve. They are not exactly juxtaposed on each other, there is a shift in between them. So, the transgressive stages, they are relatively shorter, as we can see in this particular plot. They are relatively shorter in terms of their duration, in terms of their time interval. In fact, they are even less than half of a complete cycle when we compare that with respect to the overall regressive stages, because there are three distinct regressive stages: initially normal regression, followed by a forced regression, followed by another normal regression, which occupies a major part of one complete cycle of base level change. And this is applicable when we are considering this curve as a symmetrical idealized base level change curve. The condition may vary from case to case depending on what is the actual shape of the curve. So, the actual balance between the temporal duration of transgression and regressive stages, the time duration of transgressive phases and the regressive phases, that goes on changing from basin to basin, even within a basin from phases to phases, depending on what are the dominant allogenic controls that creates the accommodation and how much is the sediment supply under that particular accommodation condition. So, these factors together will definitely control that what will be the final nature of this base level curve, and related to that, what will be the final nature of the transgressive regressive curve. So, in reality, the turnaround point from base level fall to the next phase of base level rise, if we consider this in the shoreline area, commonly indicates a sort of offset with respect to turnaround point from shoal line regression to subsequent transgression. So, as soon as the fall in base level start changing to rise in base level condition, immediately we do not get this effect of regression changing into a transgression. So, there is always a gap in terms of time period, gap in terms of phase change. So, the subsequent transgression will start after a certain phase when the rising base level will gather some pace, the rate of rise of the base level will overpace the rate of sedimentation. Similarly, the onset of shoreline regression is separated in time from the onset of base level fall at the shoreline, because as already we have seen, the end of transgression and start of the regression, it starts at the time of when the base level is still rising, and when this point of changeover in terms of base level rise to base level fall, when that turnaround comes out, there we get a changeover from normal regression to forced regression, not changeover from transgression to regression. So, actually this shift from transgression to regression starts earlier, as soon as the rate of rise of the base level is decreased and sedimentation is overpacing the rate of rise. So, we may encounter this kind of conditions in natural outcrops, natural stratigraphic successions. So, what we can expect? We can get, say, for example, repetitive successions of transgressive and normal regressive phases, where continuous base level rise in the basin is occurring and that is outpacing the rate of sedimentation, or rate of sedimentation is outpacing the accommodation creation, and that is going on in a cyclic manner. And maybe in that kind of curve, in that kind of phases, there is no scope for getting any falling phase, any case of forced regression. Alternatively, we can get repetitive successions of forced regression and normal regression, where sea level is falling, base level is falling. So, it is resulting in forced regressions, and then the base level is rising, but that accommodation creation, that rate of base level rise is outpaced by the rate of sediment supplied into the system. So, we are getting a normal regression during this rising phase, then again the base level is falling, it is resulting in a forced regression, and this is occurring in repeated fashion. So, no transgression is occurring over there, we are just getting alternate normal regression and forced regression. So, any of these combinations of these four conditions are possible in natural systems. In this particular class, we are trying to understand what are the conditions responsible for these ideal cases, assuming an ideal base level curve, assuming rate of sedimentation as uniform. In natural system, base level curves are not ideal, they are not following ideal sine curve, rate of sedimentation varies very much. So, definitely the extent of forced regression, normal regressions and transgression, they will vary from basin to basin depending on what is the nature of the base level curve. So, we can think of one base level curve, say for example like this, something like this. So, definitely this is a phase of rise. So, within this phase of rise, we can expect some deposition over here, and that deposition is expected to get eroded because the amount of fall over here is more than the rise. So, whatever succession, say during this time this much of succession was formed, there is a high chance that during this fall this entire succession or a major part of the succession is completely eroded away. Then we are getting a phase starting from here to this phase, where we have a very small phase of fall and significant amount of rise. So, definitely we can expect a transgression over here, definitely based on the rate of sedimentation, and that will result in some sort of deposition of materials, and that is followed by a fall, two successive phases of fall. So, definitely this particular phase will be a normal regression, this will be a forced regression, this will be again a forced regression, followed by this there will be a normal regression, maybe this part is the transgression. So, it can vary like this. The durations of transgression, forced regression, normal regressions, they can vary in any manner. So, if this kind of situation goes on, what we require is there should be some net sediment accumulation at the end of the cyclic changes. Just think of this succession after this first cycle, the succession was eroded. Then during this transgression, definitely we can expect a thick succession to form. There is a chance that part of that succession will get eroded during this phase of forced regression or during this phase of forced regression. But even after that, we can get this much of succession preserved, this much of accommodation available for the accumulation of sediments. So, what is required is we require a condition of net accommodation creation through time, so that finally we get preservation of cyclic successions of sediments. So, in different areas, different basins, we can get different shapes of this base level curve, and in response to that base level curve, we get different amount of sedimentary succession formed or preserved finally at the end of this cycle. In a different way, looking at that much of preservation, we have to build up the entire story. We have to reconstruct what was the nature of the base level curve, how it has changed. So, in this class, we have tried to understand that the relation between base level curve, the rate of base level change curve, and rate of sedimentation. So, how these are controlling the accommodation and how they are controlling the transgression and regression at different phases of this base level curve. So, the final TR curve, transgressive regressive curve, it shows some sort of out of phase relation with respect to the base level curve, because the rise of the base level curve is not exactly synchronous with the change from transgression to regression. Similarly, the peak of the fall of the base level curve and its turnaround changing to start of the rise exactly is not synchronous with the change from regression to start of transgression. There are some phase difference, there is some temporal gap in between these two curves. So, these are some of the references which you can follow for further reading on this particular topic. So, thank you everybody.